Ever find yourself wondering what's really going on inside your computer? Well, today we're pulling back the curtain and taking a look at the secret life of a computer process.
Think about it. You've got your web browser with a dozen tabs open, you're streaming music, maybe a game is running in the background, all at the same time. How in the world does your machine keep all of that straight without just giving up?
Well, it turns out it's not magic. It's actually a really fascinating and honestly kind of strange story that's happening deep inside your operating system. And it's a story about cloning, total identity changes, and even digital ghosts.
All right, so let's start with the absolute basics. The main character in our story is something called a process. This is the fundamental building block of all multitasking.
You see, a program, like your web browser, is really just a lifeless file sitting on your hard drive. It's just code. But the moment you double-click it, the operating system brings it to life. It creates a process, which is an active, running instance of that code, with its own memory, its own resources, its own little life. And to keep track of all these living things running around, the operating system gives each one a unique number. We call it the process ID, or PID for short. It's basically a social security number for your programs, making sure the OS knows which one is your browser and which one is your music player. Okay, so how do new processes get created? Does the operating system just build them from scratch every time? Nope. It does something way more efficient and way weirder. It clones. And it all starts with a system call called fork. When a process calls fork, it's literally like hitting a biological clone button. The operating system creates a brand new process that is a nearly perfect duplicate of the original. We call the original the parent, and you guessed it, the new one is the child. So here's the clever part. If they're identical clones, how do they know which one is which? Well, the fork function gives them a little clue. It returns a different number to each of them. In the parent, it returns the process ID of the new child. But in the child, it returns 0. And that one tiny difference is everything. It's the signal that lets the two processes go their separate ways. Now, the child doesn't just get a copy of the parent's code, it also inherits the parent's environment. You can think of this like inherited family knowledge, a bunch of variables that tell the process where things are and how the world works. But crucially, once the child is born, its copy of that knowledge is its own. It can learn new things or change its mind, and it won't affect the parent at all. Okay, let's pause for a second. Why on earth would you go to all the trouble of making a perfect clone just to have it run the exact same program as its parent? That doesn't really help with multitasking, does it? It seems kind of pointless. And you'd be absolutely right. Cloning is just step one. To actually do something new, that clone needs to undergo a radical transformation. And that's where exec comes in. The exec function is one of the most powerful ideas in computing. It completely, and I mean completely, replaces the program that the process is currently running. It throws out all the old code and all the old memory and loads a totally new program in its place. It's not just a new set of instructions, it is, for all intents and purposes, a complete brain transplant. But here's the mind-bending part. Even after that total transformation, the process ID, that unique identifier, stays the same. The process is still the same person as far as the operating system is concerned. It just has a brand new purpose in life. It's the same container, just with entirely new contents. So now we have the two key ingredients, cloning with fork and transformation with exec. So let's put it all together and see how this amazing dance happens every single time you use your computer. Think about when you type a command into a terminal, something simple like ls to list files. First, the shell process forks itself, creating a child. That new child process immediately says, I don't want to be a shell, and uses exec to transform itself into the ls program. All the while, the original parent shell just waits. Once the ls program is done listing files, the child process exits and the parent wakes up, ready for your next command. And that third step is made possible by another system call, wait. This is how the parent-child relationship is managed. The parent can use wait to literally pause itself, patiently waiting for its child to finish its job before it continues on its own way. So we've seen how processes are born and how they find their purpose. But what about the end of the line? Well, as you've probably guessed by now, even the death of a process has its own strange little twist.
A process's life can end in one of two main ways. It can finish its job, do everything it was meant to do, and then call exit to terminate gracefully. Or things can go wrong. It might crash, or you might force quit it. In that case, it's terminated by an external signal.
But this brings up a fascinating question. We know the parent should wait for the child to finish. But what happens if it doesn't? What if a child process ends and its parent never bothers to check in?
Well, that's how you get a zombie process. Seriously, that's what they're called. A zombie is a process that has finished its work, it is technically dead, but its parent hasn't acknowledged its death yet, so its entry stays in the operating system's process table, taking up space. It's a digital ghost, an echo of a program that's no longer running, just waiting for its parent to finally clean it up.
So the next time you're juggling a dozen applications and your computer starts to slow down, just remember the secret world buzzing away under the hood. The constant cloning and transformation, the patient parents and wayward children, and yes, maybe even a few digital ghosts haunting the system. It's this incredible, elegant dance that makes everything you do on your computer possible.